story. I don't know if I told you guys, the science department has managed to spend half of their budget already in printing. I know, it's a real big problem. So I need to be a cheapskate, and a lot more things are going online. If I feel it's essential, it's going to get printed. If I don't feel it's essential, it's going online. Okay? Sorry. The other thing we're doing, because, budgets, so I really like how our school is very mindful about cost of education, and we try to remove as many costs for you guys as possible. So one of the things we do here that we didn't do at my previous school is that at my previous school, we would ask students to buy the SciPads. Here, we just give them to you. With the SciPads, that comes out of our science budget. So one of the things we have to do, how there's I'm going to stop the recording so this isn't going anywhere. Actually, no, it's not that big of a deal. All right, so you know how we have our books? Yep. My class has the microbes books now. They are not allowed to write on it because we need to recycle them for next year because they are so expensive to buy, and we want to buy quite a few books. We can't afford, as a department, to buy both the internal and the external books for them. There's also a lot of new level 1 standards that are out there that you guys, luckily, they're actually really good. I think they're good. I think they're better. We want to make sure that they are able to write in the external book because that, to us, is a more important priority. The internal book we're kind of using as a guideline to help us with our teaching, but it's not necessary. We could come up with our own resources and stuff. It's just to help save us time as teachers. That's the other reason why it's really good that we use resources like that. So they are writing all of their answers from the SciPad in their notebooks instead of on the SciPads themselves. So this is the unfortunate cost of education and the challenges that we're kind of facing in our situation. So, but we are trying to be clever about things. All right. So that's why a lot of things are going online. Okay. And it's a compromise too, because I don't necessarily always want you guys online because you can get easily distracted, but it is what it is. And also I trust you guys. Okay. So this activity here, I wanted you guys to organize these molecules into two different ways. So there was one set that had 2 groups, and there was another set that had quite a few groups. What do you guys remember from doing this activity? There was one group that was really easy to figure out, and the other group was way, way harder. And I can pull it up for you guys to see it. Or do you guys want to do this activity again? You want to do the activity again? Okay. It is a worthwhile activity to do. So go back to lesson number 1, open this document up. I put it in a Google Doc so that way you can actually, if you want, copy and paste and reorganize it, or you can just kind of make notes on your piece of paper, and then I can go over kind of the answer. But there's 2 trends I want you to find, okay? The first trend is thinking about, or I shouldn't say, the first trend is very easy because it's going to be 2 categories. It's going to be 2 groups. The second trend is going to be a little bit harder. It's going to be it's going to be many little groups. Does that make sense? Okay, go for it. Okay, so the easy one I'm going to do for you guys, because then you guys know what I'm talking about. Okay, the first way to group these organic molecules, so you see how these organic molecules have carbon, and then a lot of them have oxygen, nitrogen, hydrogen, chlorine in one of them. The first way that we group organic molecules is by number of carbon. 1, 2, 3. That one has 3 carbons. 1, 2, 3, 4. That one has 4 carbons. 1, 2, 3. That has 3 carbons. 1, 2, 3. That has 3 carbons. That's one group. Does that make sense? One method of grouping. So I would group all these, I would group this one, and this one together because they all have 3 carbon. That's one method. You need to think of another way to organize these guys.
Because that's the drawn version, we have to name it.
I'm just giving you an introduction right now. Don't worry about it yet. This is the drawings of organic molecules. I haven't given you the names because I don't want you to worry about names right now because that's going to make it a lot worse. But just notice here, so if I was trying to classify these groups of organic molecules, that one's a 3, that one's a 4. That one's a 3, that one's a 4. Because I'm counting the number of carbons I see, the number of C's. 1, 2, 3, 4. That one is also a 4. So that's 4, that's 4. 1, 2, 3. That one's a 3. So we're grouping our carbons by the number. This one is 1, 2. So that only has 2 carbons. 1, 2, 3. That one has 3. Okay, that's one way I have grouped them. There is a second way you can group them, not based on number, something else. Try to figure out that puzzle. Okay. The other thing I want you guys to think about when grouping them with your methods is something called functional groups. So functional groups are a specific kind of, it's either it's like a combination of things that need to happen. Either you have to have certain elements in there, or you might need to have a double bond somewhere. It's got different sort of things. So, for example, when we are looking at things, let me actually pull up the answers. You can see it. So, when I'm talking about functional group, I am talking about these guys here. So before, the easy classification grouping is number of carbons. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc., etc. That one's easy. You guys should hopefully be able to count. The second thing that we do to classify organic molecules is by something called a functional group. And what that is just talking about chemically, these guys behave in a certain manner, and they have certain properties to it. So for example, if I look at the molecule, does it have an oxygen in there? Does that make sense? Now, it's not as simple as does it have an oxygen there, does it have a double bond there, because it's going to be specific combinations of stuff that will then cause the different categories to occur. So we're talking about categorization right now. Like I said, there's new level 1 standards that are actually talking more about the different methods of science and investigations. Unfortunately, we're very stuck on the idea of fair testing. So how to do like the experiments you guys have been doing for years and years and years. So basically control variables, independent variable, dependent variable. That is one form of science. The review of NCA has allowed us to realize, actually, we aren't very good at talking about the different types of science. There's more types of science methods. And that's what they're now doing at level 1. I'm just trying to think where I might have put it. I can find what I'm talking about, or I can show you what they're working on. But one of the key things about science is making observations and noticing things. That's probably the first step of all science, is that go, hey, I wonder why that's happening. You see something and you're like, I want to explain it. So in this case, we are looking at these organic molecules and we're trying to notice something. We're trying to now see a pattern. Pattern seeking is another form of scientific investigation. We're trying to see what's going on consistently. So number of carbons is a pattern. Does it have an oxygen is a pattern. And when we have that information, we can then go on to another type of science, which is, or not scientific method, which is classification keys. So trying to decide what something is. It's like when you see an animal, the reason why we know what the animal is because we as humans have discovered we have made a classification key, and we've decided, oh, this animal belongs in that group, that animal belongs in that group. And now that I'm realizing my random weekly question, that was actually a really good question to ask you guys, because that was an example of a classification key. I did that by accident. Like, seriously, I just did that by accident. But, so, that was pretty cool. Anyway, organic molecules, we think about things like that as classification keys. There are a lot up there. I want to make sure you are aware you are not doing all of them this year, okay? In fact, when I was at uni, I didn't do all of those either. So if I was to go up, the ones that you guys are going to be doing for this year is alkane. This one here is just a simple carbon molecule. And that carbon molecule only has a single carbon-carbon bond. And it's only made up of carbon and hydrogen. So if you look through that sheet there, you'll be able to find things that only have carbon and hydrogen and only have single bonds. Those you would put into the alkane group. The next one is the alkene group. And I'm very, very sorry that organic chemistry is like this, but the words are going to sound very, very similar. It is not a fun time. So this is A-L-K-A-N-E. You change the A to an E, and now we're talking about something completely different. I am very sorry, but this is how it is. Alkene. Now, the way I like to remember it's in alphabetical order. So A comes first in the alphabet, 1. The next vowel, E, 2. Or the next letter in that, 2. This one has a double bond, and this double bond is between 2 carbons now. Carbon, carbon. Yep. All right. Alkyne, that little E is turned to a Y. Y is at the end of the alphabet. I think 3, third one. Triple bond. Yeah? Okay. Alcohol, you will be doing as well. Alcohol, you guys have experienced it and seen it around. Like, you know how you spray the desks to clean it? That's an alcohol. That's ethanol. So, alcohol, its annotation of when you know you have an alcohol is you have an OH attached to it. So you have oxygen with a hydrogen attached to it. Now, there are other instances where you have an oxygen attached to a hydrogen, like over here, the carboxylic acid. Yeah? But the carboxylic acid is not classified as an alcohol because what it has as a difference to the alcohol is it has the C double bond O. Yeah? Now, we nicknamed that C double bond O carbonyl. I'm teaching you that word now because I'm going to be referring to things as carbonyls. So what other molecule has that C double bond O? You see the one to the left of it? They both have it, right? So these both have carbonyls. But they're not grouped together because there's slight differences between these guys. And the reason why we're not grouping them all together is because chemically they behave very differently. This one's an acid. These two are not. This is not very reactive to ketone. So we'll do carboxylic acid, we'll do ketone, we'll do aldehyde. The aldehyde is different from the ketone. They both have the C double bond O. The difference is the aldehyde is at the end, whereas the ketone is in the middle somewhere, basically not end. All right? We won't do ether. We won't do this one. We will do haloalkane. X is just referring to halogen. What are halogens? You guys remember?
The group on the periodic.
The group on the periodic table, group 17. So chlorine, bromine, my brain's coming up like fluorine, those guys. All right, we did those ones. You won't do this one. You will do ester. With the ester, again, you have a carbonyl. Yeah, no, sorry, Esther, you're being called out. You do have the carbonyl, but the difference here is that you see how this carbon is not attached to another carbon. It's instead attached to an oxygen. That is an ester now. Don't worry, you don't have to memorize this all today. We will do lots of practice of that. Amide, again, you see how you have the carbonyl? But the thing that changes with the amide is that you have a nitrogen with two hydrogens attached to it. So that's how that one's changed from this guy. Again, different properties. In fact, oh no, sorry. Never mind. Different properties. Aldehyde, you guys will see as well. So this one, again, carbonyl, but with a halogen attached to it. The one we are going to probably be using is acid chloride. So you don't have to worry about all the other ones. We're not going to do anything with the benzene. That's that big hexagon? No. Yeah, it's hex. Hexagon with the alternating double bonds. So those lines there refer to having a double bond. So it alternates. Each line in organic chemistry, when we're talking about it, that is referring to a carbon. So in those corners are carbons. And if I have an offshoot like this with nothing on it, that's also a carbon. This is our shorthand for chemistry. All right. We won't do, I think, most of the bottom ones. So all these bottom ones are gone except for the amine. The amine is, again, that nitrogen with the hydrogen, but what is it missing now? The carbonyl. Now that is a big difference because this is basic. This one is not. The amide. Yeah? So those are things you got to keep in mind. This is what the classification is. So when I gave you guys this sheet over here, that was what I was hoping you guys would find. I didn't have the time to prep for it like I would have liked to. I would have liked to give you guys actually cut out and you can move it around because I feel like that works the best way to kind of learn it. But it's all about thinking about categories and classifying and patterns. Right, any questions so far about that? Where did my eraser go on the board? Okay, so let us move on. So I know you guys are in lots of different places. So basically what I'll do then is we will go through lesson number 1 and we will put lesson number 2 on hold for Friday. And that might probably mean then that those that need to do the second attempts or finish up the assessments now get to do it on Tuesday. Get an extra day now. because you guys procrastinated. Okay, cool. Let me just pause the note.